Hello Reason users. In this video, we'll take a closer look at pearls, a rack extension built for adding rhythmic and melodic elements to your Reason setup. We'll go over what it does, how it works, and where it might fit into your workflow. Pearls is a player device we designed for Reason, focused on generating MIDI sequences and arpeggios. While it has many features, our aim was to make it intuitive once you understand its core concepts. Whether you're specifically interested in Euclidean rhythms or just need a flexible new sequencing tool, we've built pearls with a range of functions we hope you'll find useful. Let's begin by looking at the interface. Up top, you'll find the standard Reason patch browser for saving and loading your pearl settings. Down at the bottom, there's a play and stop button for the internal generator, a mute button, and a comment field for your patch notes. The main functionality is organized into these three core sections. First on the left is the rhythm generator. This is where you can explore Euclidean patterns and other rhythmic structures. Second, the central area houses the sequencer section, which contains 4 independent sequencers. And third, on the right, is the note mapping section. This area also allows you to switch pearls between its classic sequencer behavior and a dynamic arpeggiator. Let's explore these parts one by one, starting with the rhythm generator. The rhythm generator is the engine that drives pearls. It has 4 distinct types. You can cycle through them by clicking and dragging on the type field, or by using the up and down arrows next to it. The first type is pulses. This is the most straightforward mode. You can set it to be either cycle-based or step-based. When it's in cycle mode, you define the cycle length, which can range from 2/4 up to 64/4. Then you set the number of steps within that cycle, from 1 to 32. We designed this to be useful for creating polyrhythms against your song's main time signature. If you switch to step mode, you're now defining the length of each individual step, from half notes down to 1/64 triplets. The overall rhythm length is then determined by the number of steps. This can be used for exploring polymeters. This display visualizes your rhythm, and its appearance can be customized. The second type is Euclidean. This mode introduces parameters specific to Euclidean rhythms. First, there's events. This is the number of active pulses you want within your total number of steps. Pearls distributes these events as evenly as possible using the Euclidean algorithm. This mathematical concept often produces rhythms found in various musical traditions. Experimenting with different step and event counts, especially relative primes, can yield interesting patterns. Next, we have direction, which lets you flip or mirror the rhythm. And finally, offset, which shifts the entire pattern. The third type is Altered Euclid. This mode takes your Euclidean pattern and allows you to introduce controlled random alterations. There are 2 parameters here, R&D depth and R&D seed. R&D depth determines how many times pearls will swap an active event with an empty step. R&D seed ensures these random swaps are reproducible. If you use the same seed, you'll get the same altered rhythm. Changing the seed will produce a new variation. This can be used for adding subtle, or more significant changes to your patterns. And the fourth rhythm type is Euclid collision. This is the most complex mode, allowing interaction between two Euclidean rhythms. Here, you're working with an A rhythm, shown in ochre, and a B rhythm, shown in pink. The final output, shown in orange, is determined by a logical operation between rhythm A and rhythm B. You can choose from various Boolean operations like A and D, which means an output occurs only if A and B are active. OR, where an output occurs if A or B is active. XOR, and others. This matrix can help visualize the Boolean logic. The goal here is to provide tools for creating complex interactions and for controllably altering rhythmic patterns. There's also an operation mode called random choice. In this mode, Perls randomly picks between rhythm A or B for each step. The balance knob lets you adjust the probability of choosing A versus B. And again, the random choice seed ensures reproducibility. The gear menu in the rhythm generator section offers context-sensitive utilities, like copying settings between rhythm A and B in collision mode, or some quick presets. Also, this number on the display shows the total number of active events in your final rhythm cycle, which can be a useful reference. Now, let's look at the central sequencer section. Perls includes 4 independent sequencers, one for notes, one for velocities, one for note lengths, and one for selection, which functions as a probability gate or a filter. Each sequencer has 8 lanes and can have its own length, from 1 to 32 steps. These sequencers advance 1 step each time the rhythm generator produces an event. Each sequencer also has its own length setting and a sync-async switch. When in sync mode, the sequencer restarts every time the main rhythm generator completes a cycle. When in async mode, the sequencer continues independently of the rhythm generator's cycle, only resetting after it completes its own defined length. This independence between rhythm events and sequencer steps is a core feature we designed for creating evolving and generative musical patterns. Let's look at each sequencer type. First is the notes sequencer. Here, you use on or off bubbles for each step in each of the 8 lanes. You also have 4 distinct note patterns per patch, which you can switch between using these buttons labeled 1, 2, 3, and 4. Next are the velocity, length, and selection sequencers. These 3 use a bar graph interface. You can click and drag to set values from 0 to 100. For editing these, hold Shift while dragging for fine-tuning. The bar will turn blue. Hold Alt or Option to edit all lanes simultaneously. And you can Control-click on a PC or Command-click on a Mac to reset a step to its default value. Regarding the velocity sequencer, the values here, from 0 to 100, are mapped to a final MIDI velocity from 1 to 127, using these 2 map knobs labeled From and To. This mapping allows for dynamic control. For instance, if you set both knobs to the same value, all triggered notes will have that exact velocity, regardless of the sequence. Or, you can create accents and quieter notes by adjusting these knobs, even during playback, without altering the program sequence. Then there's the length sequencer. It's a similar concept, but these values map to note lengths. These can range from 6.25% up to 1600% of the current step length, defined by the rhythm generator. This allows for very short staccato notes, or notes that sustain for many steps. The map knobs provide real-time control over these lengths. And the last of these 3 is the selection sequencer. This acts as an additional gate for your notes and has 2 modes. The first is probability mode. In this mode, the sequence values are mapped to a probability from 0 to 100% that the note will actually play. 0% means it never plays. 100% means it always plays. This can be used for adding evolving variations. The second mode is limits mode. This offers more deterministic control. Here, the knobs set a lower and upper limit. A note only plays if its corresponding sequencer value falls within this range. This is useful for gradually bringing elements in or out of your sequence. The sequencer section also has its own gear menu. This contains presets, randomization tools, shift functions, and other utilities. And this overview button lets you see all 4 sequencers at once, which can be helpful since each can have different lengths and sync modes. Now let's look at the right-hand side of Pearls, the note mapping section. This section determines the actual pitches assigned to the 8 lanes of your sequencers and has 2 main modes, which you can switch between right here. The first mode is predefined mode. This is classic sequencer behavior. You define fixed MIDI notes for each of the 8 lanes. You can adjust notes individually by semitones or octaves, or adjust all notes simultaneously using these global controls. Pearls provides 4 preset slots for note mappings per patch, which you can switch between using these buttons labeled 1, 2, 3, and 4. This display on the right gives a visual overview, with the currently selected map shown in orange. The gear menu here includes presets for common reason drum machines and samplers, as well as various scales, chords, and intervals. It also has editing functions like ordering, shuffling, and copying maps between slots. The second mode for note mapping is dynamic mode. This enables arpeggiator behavior. Instead of predefined notes, Pearls uses incoming MIDI notes to populate the lanes. When you hold down MIDI notes, there are a couple of options. First is recursion. If you hold fewer notes than the 8 available lanes, this switch, showing either a 1 or an infinity symbol, determines the behavior. If set to 1, notes are used once, potentially leaving some lanes silent. If set to infinity, the pattern of incoming notes repeats to fill all 8 lanes. Second is ordering. These 4 buttons change how incoming notes are assigned to the lanes. You can order them from lowest to highest pitch, from highest to lowest pitch, from oldest to newest based on the order you played them, or from newest to oldest. This offers flexibility in how your arpeggios unfold. The note display fields will show the notes assigned by the incoming MIDI. Briefly, the footer. The text field is for patch notes. The play button starts and stops the internal rhythm generator, and the mute button silences notes generated by Pearls. An important note on MIDI pass-through. In predefined or sequencer mode, Pearls generally passes incoming MIDI notes straight through. So, if you're playing a keyboard or have another player device before Pearls, those notes will usually be heard alongside Pearls output. The mute button only mutes Pearls generated notes. However, in dynamic or arpeggiator mode, incoming notes are used by Pearls to create the arpeggio, so they are not passed through in the same way. And up top, the on-off switch bypasses Pearls entirely, like other Reason Player devices. Now let's look at the back panel, as Pearls also offers extensive CV capabilities. For CV inputs, there are 3 CV inputs. These allow you to modulate the current values of the velocity, length, and selection sequencers externally. For CV outputs, Pearls provides a comprehensive set of CV outputs. First, notes and gates. These are standard note and gate CV outputs for each of the 8 lanes. Next are toggle CVs. There are 8 of these. Each time a gate is received for a lane, its corresponding toggle output flips its state. And finally, sequencer value CVs. For each of the 8 lanes, you get direct CV outputs for the current values from the velocity, length, and selection sequencers. This amounts to another 24 CV outputs. These CV outputs allow for deep integration with other devices in the Reason rack. Some users even utilize Pearls on a muted instrument primarily as a multi-channel CV sequencer. That covers the main features of Pearls. Before concluding, we'd like to show a quick creative pairing example, as player stacking is a powerful aspect of Reason. First, we'll add an instance of Pearls to drive a chord progression. We'll set this first Pearls to predefined mode. We can create a slow rhythm with long notes. perhaps a 4-step sequence in an 8/4 cycle, and we'll use the length sequencer to ensure long notes. The note sequencer can draw a simple, monophonic bass line or root note progression. Second, we'll add a chord player. Next, we can add a chord player like Reason's Scales and Chords, or another similar device. This will take the single notes from our first Pearls instance and generate full chords. And third, we'll add another instance of Pearls to act as an arpeggiator. This time, we'll set it to dynamic, or arpeggio mode. We can program an interesting, faster rhythm in its rhythm generator, and perhaps draw a pattern in its note sequencer. This pattern will now select which notes of the incoming chord get played by the arpeggiator. And here's the result: an evolving arpeggiated chord progression, driven by Pearls. This is just one example of how these features can be combined. So that's Pearls, our Euclidean collision sequencer, and arpeggiator for Reason. It's a deep device, and we hope it provides you with a flexible tool for new musical ideas. Thank you for watching.